Hello students! So this video here is about angle terminology and equations. Alright, so guys, in our most recent video, in our latest lesson before this one, we talked about angle terminology and relationships, and we went through certain angle terminology as well as different basic types of angles, and we talked about certain types of angle pairs, and we went through 5 types of special angle pairs, and those 5 types of special angle pairs that we went through in our most recent lesson and video were adjacent angles, vertical angles, complementary angles, supplementary angles, and linear pairs. But again, we talked about a whole lot, and even more than that in that last video. But so we're going to kind of continue sort of with that. We're going to add in some new information, and we're still going to kind of be dealing with some of those special angle pairs. And here we'll kind of be looking at different examples, especially with equations. And equations with variables. So let's go ahead on and get started with that. So guys, we're going to go ahead on and kick this thing off by starting off talking about the angle addition postulate. All right, so again, we're going to start off by talking about the angle addition postulate. So folks, I don't know if you remember, but maybe a few lessons ago, talking to my students enrolled in my classes at our school, a few lessons ago, we discussed the segment addition postulate, where you could take the lengths of 2 segments that are right beside each other and add them together to equal up the length of the entire segment. So the angle addition postulate is sort of similar to that, except for it's with angles. All right. All right. So guys, the angle addition postulate states that if point D is in the interior of angle ABC. All right. So here, guys, you see this diagram. You see we've got an angle ABC. That angle right there, and you see where point D is somewhere interior, somewhere in the interior of that angle. It's not somewhere outside of the angle like over here. You see where I'm putting that? It ain't nowhere out. It ain't anywhere that's exterior in the angle. Point D is interior in the angle. But anyway, so if point D is in the interior of angle ABC, then what must be true is this. The measure of angle ABD the measure of angle ABD plus the measure of angle CBD has to be equal to the measure of the whole angle, the measure of angle ABC, okay? All right, so again, folks, and you can see based on the diagram, the measure of angle ABD based on the diagram was 60, yeah. All right, and the measure of angle CBD based on the diagram was 40, right? Yeah. All right, so the measure of angle ABC has to be those 2 smaller angles added up together. That's the angle addition postulate. When you've got, and really, for the most part, it doesn't just work with adjacent angles, but most of the time when we see diagrams, it works that way when we've got adjacent angles like what you see in this diagram. All right, so let's look at example 1 here, where we're dealing with this diagram here, and in this diagram we've got complementary angles. All right, so folks, as you can see in that diagram, they've got these 2 angles here, and you should notice that little symbol there in the corner that we talked about when we had introduced right angles and when we were talking about the Pythagorean theorem and everything like that. So you should see that little symbol that looks like a little box in the corner of that angle, letting you know that this big angle is a right angle, or the big angle is a total of 90 degrees. And so guys, since these 2 angles come together to form a right angle, or these two angles pretty much add together to give you 90 degrees, that means that, of course, they're complementary angles. So, guys, if we write out the angle addition postulate with that, then let's go ahead on and do that. So let's see here. The measure of angle, and we're going to try to write this out right here. Hopefully that don't look too sloppy. The measure of angle, LOM, plus the measure of angle. Okay, I'm not going to be able to write it right there, am I? Nope. All right, let's try that again, y'all. Give me just 1 second, y'all. 1 second. 1 second. All right, the measure of angle, LOM, plus the measure of angle, what that other angle is, MON. So those two smaller angles added together equal to that bigger angle, the measure of angle LON. So guys, we know that the measure of angle LON is definitely 90 degrees, right? And really, when we're writing it out like this, we don't have to write the degree symbol, not as part of this equation. All right, and so what we do know, what they tell us in the diagram is that the measure of angle LOM is 2x plus 46, and they tell us that the measure of angle MON is 3x minus 6. All right, so we've just written out the angle addition postulate for this diagram here, and we're substituting those expressions that we know. So we know that the whole thing there adds to 90, because again, these are complementary angles. And you know that because of that right angle symbol that's right there in that corner. That you know that these two angles form a right angle. They add to 90 degrees. All right, so let's combine our like terms, the 2x and the 3x. That gives us 5x. Excuse me, guys. I'm just going to go ahead on and write that out. The 46 and the negative 6. That gives us 40. So that is 5x plus 40. If you combine the like terms that are on the left side of this equation, all right, and it's still equal to 90. All right, then guys, if we subtract 40 from both sides, that is going to give us 50. So 5x equals 50. And then guys, the last step there is solving, dividing by 5 on both sides. And if we divide by 5 on both sides, we end up getting that x equals 10, right? Now, are we done? Certainly not, because they didn't ask us to find x. They said find the measure of angle MON, right? Find the measure of angle MON. So guys, according to the diagram, the measure of angle MON is that variable expression 3x minus 6. So guess what? We're going to have to use that expression 3x minus 6, because that's the expression that's technically equal to angle MON. So let's use that expression of 3x minus 6, and let's go ahead on and substitute in our value for x that we've got there. Let's substitute that in there. Okay. All right, so let's go ahead on and do that. Let's substitute that. So we got here that the measure of angle MON, because that's what we're actually trying to find, is supposed to be 3x minus 6. Let's substitute what we got here. All right, so we've just found the value of x is 10, right? So that's 3 times 10 minus 6. If we substitute that value of x into this equation, 3 times 10 gives us 30. So that's 30 minus 6. And guys, 30 minus 6 is 24. So if we were going to write out the answer for this, our solution here is going to be that the measure of angle MON is equal to 24 degrees. All right. Okay, yeah. That doesn't really look like a degree symbol. Give me a second now. A little bit better. Not much. Ah, there we go. All righty. 24 degrees. That's our solution right there. All right, we're going to look at some more examples, not only just with complementary angles, but with some other types of angles too. Okay, so guys, next up we're going to look at an example where we have angles that are adding up to 90. But guys, in this next example is not just going to be two angles. It's going to be more than two angles that are adding up to 90. So here's the thing. When it's two angles that are adding up to 90 degrees, we call those two angles, that angle pair that adds up to 90 degrees, we call that complementary angles. But what do you call it when it's more than two angles? Well, actually, folks, I'm not really sure what you actually call it when it's more than two angles that add up to 90 degrees. Now, maybe there is a specific name, but I don't know what it's called. What I do know is that when there are more than two angles that add up to 90 degrees, like for instance, if there were three angles here that added up to 90 degrees, we would definitely not call those three angles complementary angles. In order for you to call some angles complementary angles, it needs to be only two angles. Only exactly two angles. In order for you to call it complementary, it has to be two angles that are adding to 90 degrees. It can't be more than two, can't be less than two. It's got to be exactly two angles that add to 90 degrees. So this next example, we're going to look at what happens when we got more than two angles that are adding up to give us 90 degrees. Okay, all right, so again, folks, as you can see here with this diagram, right there, that diagram, in example 2, guys, when we have more than two angles that add, when more than two angles add to 90 degrees, that set of angles is not called complementary angles. Again, it's only called complementary angles when you have exactly two angles that are adding to 90. It can't be more than two angles. It can't be less than two angles. You get what I'm saying? You dig good. All right. All right, so let's look at example 2 here with that diagram where it has to find x. So let's write out our angle addition postulate. So folks, with this particular diagram, they don't have any way for us to actually name these three angles, or technically these four angles, the big one included, the three smaller ones and the big one that they add to. But guys, even though we don't have a particular way of naming these angles, we do know that again, we do know what these three small angles add to. Okay, I thought that was going to look a little bit neater than that. Give me a second here. All right, there we go. We do know based on that symbol, that right angle symbol, and you guys might be able to barely see it, but if you look closely, if you look real closely, you can see that symbol that's in that corner. Now it's drawn in black, but you can see that. Okay, yeah, it's there. Oh, it's there, all right. All right, and so based on that symbol, guys, we know that these three angles there add to 90 degrees, okay? So we can write out an angle addition postulate based on knowing that those three angle measurements, that one that says x plus 3 degrees, x minus 1 degrees, and x plus 1 degrees, all three of those angle measurements have to add to 90 degrees. And we'll write out an angle addition postulate based on that. Okay, because that does have to be true. All right, so again, the measurement that we've got for that first one, x plus 3. I don't know where that squared came from. All right, x plus 3 x plus 3 plus x minus 1 plus x plus 1 equals 90 degrees. All right, again, I'm not going to put the degrees only because we're dealing with this equation here, and we know that we're dealing with a unit of measurement that is degrees. But anyway, all right, so let's combine our like terms. We've got these x's over here that are on the left side of the equation. So out of all these x's, how many x's do we have in total? That's 1, that's another 1, that's another 1, that's 3 x's, right? Awesome. Combine our like terms. Okay, we've got these numbers on the left side, these constant terms on the left side, the 3, the negative 1, and the positive 1. And we need to combine those like terms. So when we combine the 3, the negative 1, and the positive 1 that are on the left side of the equation, we end up getting positive 3 when we combine those 3 constant terms. All right, so on the left side of the equation, after combining our like terms, we end up with 3x plus 3. All right, so that's 3x plus 3, and then we still have this equation equals to 90, right? All right, so let's finish solving. Let's subtract 3 on both sides, so we can get all our constant terms on the same side of the equation, away from our terms with variables. All right, so that's 3x equals 87. Cool beans. All right, if we divide by 3 on both sides, that's going to wind up giving us the fact that x equals 29. Yes, x equals 29. 29. Yes. All right, so x equals 29. All right, and again, guys, we're not going to put degrees because they have degrees here for the angles of those measurements. Now, if we were going to plug in x into one of those things, I'm going to erase this after I get done with that. But if we were going to plug in x into one of those things there, like x plus 3, where that says degrees. If we were going to plug in, that's just a sloppy, but it's all good, y'all. If we were going to plug in x into one of those, and do 29 plus 3 to find out how many degrees that angle is, y'all get what I'm saying? You dig? You could dig me? You feels me? You feel me? Okay. All right, cool. If we were going to plug that in to figure out what those angle measurements are, like this angle here would be equal to 32 degrees, then we will put the degree symbol if we were actually talking about the measure of one of those angles. Y'all get what I'm saying? But we're not talking about the measure of one of those angles when we just say x. Okay? When we say x, we're just talking about the value of that variable x, which is 29. And the value of that variable is 29. But that's not the measure of any of these angles. That's just the value of x, okay? All right. So if we had to find the measure of one of those angles, we would just plug in that value of x. All right, and like I said, this angle here would be 32 degrees, but I'm about to erase all of that right there. Erase all of that. I'm erasing all of that because they ain't asked us to find all of that. They ain't asked us all of that. All right. So again, guys, x equals 29, and that's our solution. Yes, that is our solution. Our answer, our solution. Yes. All right, so let's look here at this third example here. And this one, if you're looking at the diagram right here, yeah, you see it. You see that diagram. Act like you don't see that. If you're looking at that diagram there, you can see that we've got two angles that are forming a straight line. It's a linear pair. And again, guys, we know that any linear pair, any two angles that are forming a straight line like this, because every straight line is 100. So every straight line or every straight angle is 180 degrees. That means that these two angles right here add to 180 degrees, which means that they are indeed supplementary angles. Because again, a straight line, or the measurement for a straight line or a straight angle, is 180 degrees. So these two angles add to 180 degrees, which makes them supplementary. Alrighty, so guys, in this example, they want us to find the measure of the obtuse angle. So guys, in our most recent video, in our previous lesson that we went over, where we started talking about angle terminology, I reminded some of you and introduced to others of you those 4 basic types of angles. And one of those basic types of angles was obtuse angles, right? Yeah. All right, so guys, remember that obtuse angles are angles whose measurements are greater or bigger than 90, or angles whose measures are in between 90 and 180, in between 90 degrees and 180 degrees. All right, so guys, if you're looking at that right there, that I just put there, I kind of got that there just to kind of make sure that everybody knows what we mean when we say obtuse angles, right? So as it stands right now, these 2 angles that you're seeing right here, this one and this one, would be, or at least right now, what we can say is that they look like right angles. They look like they are 90 degrees. Now again, we don't know that they're 90 degrees because we don't have any definitive proof in this diagram. We don't see a right angle symbol there, and we don't see an actual angle measurement of 90 degrees written. So again, right now, we just say that they look like they're 90 degrees, these 2 angles. Now, again, guys, based on what we're looking at here, we should know what it looks like when an angle is bigger than 90. All right. So as it stands right now, this angle that's on the left side of this would be obtuse, or greater than or bigger than 90. So this angle that's here on the left side would be considered obtuse, most definitely, even though we don't have any way right now of measuring it. Just based on the way it looks, guys, it's definitely bigger than, excuse me, give me one sec. It's definitely bigger than, trying to draw something that sort of kind of looks straight. Yeah, okay, I ain't no robot, so this ain't gonna look perfect. It's definitely bigger than that, right? It's bigger than if it was like an actual L shape. Okay, so it's much bigger than that by however many degrees. This angle on the left side is larger than that. Okay, so give us at least that much credit. All right. So because it's bigger than 90 degrees and it's less than 180 degrees, it is obtuse, that angle there. Again, guys, the angle that's on the right side of this would be considered acute because it's technically smaller than a right angle, or it's in between. The measurement of it would be in between 0 and 90 degrees. All right, so I'm going to erase all of that right there, But again, guys, if they say find the measure of the obtuse angle, they're talking about this this measurement that is right here on the left side. They're talking about this one here, okay? They say find the measure of the obtuse angle. That right there be the one they're talking about. Lord, I'm making that look so sloppy, but it's all good. It's all good, y'all. All right, there we go. That's a little bit better. All right, I'm about to erase all that right there. Big eraser. Okay. All right, let's go ahead on and do this here. All right, let's set up the angle addition postulate for this. All right, again, folks, remember that these 2 angles are supplementary because they form a straight line. They form a straight line, and you can see that straight line there. It's like half of a circle, right? And we know that the whole the whole measurement for a circle is 360 degrees. Oh, snap. Did y'all see it make that circle? Man, that was cool right there. We know the whole measurement for a circle is 360 degrees, right? And we're gonna come back to that in just a little bit. But we know that the whole measurement for a circle is 360 degrees. And so if we're looking at just half of a circle, what we call a semicircle, then that's 180 degrees. And when we have a line like that's 180 degrees. Okay, the straight angle that's there. All right, NT waist. All right, so we know that that's 180 degrees. All right, and so we write out our angle addition postulate based on those two angles adding to 180 degrees because they're supplementary. All right, so let's do this. Again, guys, here we don't have a way of actually naming these angles, but we do know that what these angle measurements are supposed to be. So the angle measurement, that is 2x minus 30. When we add that to the other one, which says x minus 12, it is supposed to be equal to the total amount, which is in that straight line, 180 degrees. All right, so there we go. That's based on the angle addition postulate. Let's go ahead on and simplify. Let's combine our like terms on the left side of the equation. Let's put together the x's on the left side of the equation. We got 2x, we got 1x. When we put them together, we got 3x. Cool. All right, let's put together the constant terms on the left side of the equation. Combine those like terms. Negative 30 and negative 12. When we combine those two together, we get negative 42. All right, so now we've combined the like terms on the left side of the equation. The right side of the equation is still 180. I'm going to take the degree symbol off. All right, because technically in this equation, we'll be solving for x. And x is not going to be as a degrees. Okay, x is just going to be the value that works for that variable. X is not the actual measurement of the angle. X is just the value that works. X represents the value of the number that actually works for this diagram. The value of the variable. Okay. All right. So let's do this, y'all. Equals 180. All right, and so let's add 42 there. When we add 42, we get 222. Okay. Boom, 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 boom. Nickelodeon. I say Nickelodeon. I say Nickelodeon. I say Nickelodeon. All right. Yes. Oops. Give me one sec, guys. That there. I thought I was supposed to be doing something. Yeah, we were supposed to be adding 42 to both sides. Knew something didn't seem quite right with what I had written. Plus 42 plus 42. All right, that cancels out. 3x equals 222. All right, and then the last step here will be dividing by 3. Let's go ahead on and do that. Divide by 3, divide by 3. Boom, 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 boom. All right, so guys, when we divide 222 divided by 3 gives us 74. Yes, gives us 74. I believe that there should be right. 70 times 3 gives us 210, and then there's another 12 in there somewhere, and that takes 4. Yeah, cool. 74. Awesome, cool beans. 74 times 3 gives us 222. All right, that's enough of that right there. Had to make sure that we had that thing right. Awesome. All righty. Since we ain't got no calculator on me right now. All right, so that gives us x equals 74. Now, folks, we're not done. Why are we not done? Because they didn't ask us to find x. They asked us to find the measure of the obtuse angle. All right, so we got to find what they asked us to find. Now, we did have to find x. I mean, there's no way that you were going to figure out what the measure of the obtuse angle was if you didn't find out what x was first. So again, finding x is not something that you can skip. but it's not the end result of what they're asking us to find either. All right, so x equals 74, but we still got more to do. All right, so the angle is the obtuse angle, that measurement there that he's asking us for, we're going to have to plug in our value of x there. So when we plug in that value of x to get that obtuse angle, that 2x minus 30, right? So when we plug in our value of x, plug in that 74. 2 times 74 gives us 148. 2 times 74 gives us 148. So we got 148 minus 30, which gives us 118. Yeah, that is just as sloppy, but it's all good. Got 148 minus 30, which gives us a 118 degrees. Is the measure of the obtuse angle. That's our solution right there. Of the obtuse angle. Obtuse angle. All right, awesome. There we go. 118. That'd be our solution right there. I do say now. That'd be our solution. 118 right there. All right. Okay, so guys, that example there was with supplementary angles. All right, so and remember, guys, supplementary angles is two angles that add together to give us 180 degrees. So, guys, what happens when we have more than two angles that technically come together to add to give us 180 degrees? So, if there's more than two angles that add to 180 degrees, then guys, you do not call those angles, or you do not call that set of angles supplementary if it's more than two angles. Okay, if it's more than two angles or if it's less than two angles, you cannot call it supplementary angles. Okay, supplementary angles has to be precisely two angles that add to 180 degrees. All right, so next we're going to look at an example where we're adding more than two angles, and those more than two angles that add to 180 degrees. So again, folks, when more than two angles add to give us 180 degrees, that set of angles is not called supplementary angles. Okay, like here in this diagram, what you see right there. Okay, I didn't mean to do all that, but that's okay. Okay, y'all excuse me for just a moment here. So again, folks, like with this example here, you see three angles that are adding to 180. And we know that they're adding to 180, guys, because they form a straight line. Okay, I'm going to erase that because that is just as sloppy as ever. Right? They form a straight line. And we know that for every straight angle like that, we know that a straight angle is a total of 180 degrees. Okay, and even though we do not have a linear pair like what was in that last example 3, because a linear pair again is exactly two angles that form a straight line. This is not a linear pair, even though these three angles form a line. Again, guys, a pair of angles is just two angles. So again, this is three angles here that form a line that add to 180 degrees. All right, okay, I need to erase alls of that. Okay, that's better. Much better. Much better. All right. Okay, so let's go ahead on and let's write out our angle addition postulate here. Again, folks, with our angle addition postulate, all three of these angles here are going to add to 180 degrees because, again, they form a straight line. Let's do this. All right, so let's take these three angle measurements. The measure of the biggest angle there, that obtuse angle, or at least what looks like an obtuse angle, and I'm pretty sure that it is obtuse angle anyway, even though we don't know the exact measurement of it. All right, is 5x plus 4. Now again, guys, it doesn't have to be, literally, it doesn't really have to be obtuse, but based on the way it looks, we could assume that it is obtuse or that it's bigger than 90. But again, it doesn't have to be bigger than 90. Let me make that little point, because we could find the value of x where that largest angle is literally not something that's bigger than 90. But anyway, let's go ahead on and let's finish writing out this angle addition postulate. Let's add it to these other two angles, plus x minus 2 and plus 3x minus 7. All right, so again, all three angles add to give us 180 degrees. All three of those angles add to give us 180 degrees. We shouldn't really write that degree symbol here, because in this equation we'll be solving for x, and again, guys, x is not representing degrees. X is just representing the value of whatever number works there. Okay, x doesn't really represent degrees. Degrees is going to be whatever the actual measurement is for these angles, and again, that's not x. All right, so let's go ahead on and finish solving for x here. Let's combine our like terms. Let's put all of the x's together on the left side of the equation. We've got 5x here, we got x here, sorry, 1x, and then we got 3x, 5, 1, and 3. That gives us a total of 9x. Let's put together the constant terms on the left side of the equation. We got positive 4, we got negative 2, and we got positive 7. When we put together positive 4, negative 2, and positive 7, we get positive 9, or plus 9. And so it gives us 9x plus 9 on the left side of the equation. On the right side of the equation, it's still equal to 180. Let's go ahead on and subtract 9 from both sides. Let's get all our constants together on one side of the equation. All right, so we do that, we get 9x, and then 9x be equal to 171. Cool beans. When we divide by 9, we should get 19. I ain't got no calculator on me, but I'm pretty sure that's going to have to be 19, because 9 times 20 gives us 180. And if we take away one of those sets of 9s, it's going to have to be, just take away one of those sets of 9s, it's got to be 171. Like I said, I ain't got no calculator on me, but I'm a mathematician. So I know that got to be 171 when you do 9 times 19. That's all I'm saying. That's all I'm trying to say. You know what I'm saying? I ain't got no calculator on me, but I'm sure that that's 19. Okay, empty waste. All right, so x equals 19. That is our solution, guys. Next, we're going to look at an example with vertical angles. Guys, remember, vertical angles are those. Really quick, let me give you a little tiny reminder. Just a little tiny reminder, and then we'll look at our next example. Remember, guys, that vertical angles are those types of angles that get formed when we have two straight lines that intersect each other. So whenever you got two lines that intersect each other, you will have vertical angles. Remember, guys, that when you have two lines that intersect each other, those vertical angles are your non-adjacent. Remember, guys, adjacent angles are angles that are literally like side by side, like these two. Adjacent angles are angles that are side by side, like these two. We're not talking about angles that are side by side with a common ray and a common vertex, like these two angles right here, 1, 2, right? We're not talking about those that are side by side, adjacent angles like that. Okay, let me get rid of all that. We're talking about non-adjacent angles, like this one right here and this one. Non-adjacent angles like this one and that one that are facing opposite directions from each other. Literally, facing opposite directions. This angle opens up that way, and this angle opens up this way, right? They're not adjacent to each other, and they're facing opposite directions, right? Y'all get what I'm saying, right? So those two angles are vertical angles, and these two angles right here. Okay, I don't know if y'all can really tell, if y'all can really see how different that color is. Give me one sec, yeah. Give me one sec. And these two angles right here, there we go, are also vertical angles, right? They're not adjacent to each other, and the two angles are facing opposite directions. All right, so that's a little reminder of what vertical angles are, right? Empty waste, I'm going to erase that, and we're going to look at our next example. All right, let's try to erase that without erasing the wrong stuff, y'all. Okay, okay, there we go. Awesome, big eraser. All right, we're going to look at our next example with vertical angles. Okay, so guys, here we've got example 5 where we're looking at vertical angles. Again, guys, now some of you might, and it's really not funny what I'm about to say. Some of you might make a mistake here, and some of you might literally look at these angles right here. You see these angles? Some of you might look at these angles and you might assume that this thing right here, you see this angle that's 2x plus 5. You might assume that is a right angle. You might assume that angle is 90 degrees because, oh snap, it looks just like a 90-degree angle. You see that? Oh my goodness, it looks just like a 90-degree angle. Oh my God. Oh my God. You see that? Oh my God. Oh my God. Okay. Because it looks like a 90-degree angle, some of you are going to assume that. I told you guys already, you cannot assume that it's 90 degrees. The only way you know for sure that it's 90 degrees is if you see a right angle symbol, or if you actually have 90 degrees literally, if you literally have 90 degrees written there. You don't see 90 degrees written there, you don't see a right angle symbol, don't assume that it's a right angle. All right, glad we got that done. Now folks, what we do have here is we got a set of vertical angles. Again, as I mentioned a few moments ago, as a reminder of what vertical angles are, again, folks, you can see here that with this straight line, yeah, I'm going to erase it afterwards, and with this straight line, we got these two angles right here. You see them. You see which ones I'm talking about. These two non-adjacent angles right there that are facing opposite directions from each other. Those are vertical angles. And guys, we had mentioned that when we have a pair of vertical angles, in our last video that we made in our last previous lesson, we mentioned that vertical angles are always congruent. Always congruent. So when we have a pair of vertical angles, yeah, that's sloppy, but you know what? It's going to have to work for right now, are always congruent. So again, folks, oops, thought I was erasing that. All right. We've got two vertical angles. Okay, yeah, I just completely erased way too much. Why y'all ain't tell me I was erasing that much? Now I can't even unerase it. See there? Y'all didn't even tell me that. Anyway, so again, guys, vertical angles are always congruent. And again, in this diagram, these two angles that I have circled right here are vertical angles. Those two right there, you see them, are vertical angles. And so, guys, we know that when we say congruent, we're talking about the fact that they have equal measures, or that the measurements there are the same. So when we say congruent, we're talking about equal measures or equal measurements. So those two angles will have equal measurements. So now, if those two angles there have equal measurements, guess what? Equal measurements means that you literally set the measurements equal to each other. Equal measurements. Set the measurements equal to each other. So again, guys, for vertical angles, because vertical angles are always congruent, and by congruent we mean that they have equal measurements. Vertical angles will always have equal measurements. So because of that, guys, with vertical angles, we should set the measurements of those vertical angles equal to each other. Please do not make the mistake. Do not make the mistake of adding the two vertical angles together. Guys, the vertical angles are not complementary. They don't add to 90. Vertical angles are not supplementary. they don't add to 180 degrees. Vertical angles are, the measurements of vertical angles are equal to each other. So please make sure you set them equal. Okay, did you notice how much emphasis I put on that? Thank you. All right, let's go. Let's go ahead on and set these two equal to each other. 2x plus 5 equals 3x minus 33. Yeah, that much emphasis means it's that important. Anyway, let's go. All right, let's go ahead on and solve this. And now, guys, us doing this equation here is going to allow us to solve for x. Remember, guys, that we're not only finding x, we've also got to find y as well, okay, and y, okay? All right, so let's go ahead on and solve for x. Let's get all our x's on the same side of the equation. All right, let's subtract 2x there. That's going to leave us with 5 on the left side of the equation. That's going to leave us with 1x, or just x, on the right side of the equation. X, okay, yeah, that's sloppy. It's okay. X minus 33. All right, and on the left side, we've got 5. All right, let's go ahead on and get all our constant terms together on one side of the equation, isolated away from our variables. So let's add 33 to both sides. That gives us 38 on the left side of the equation. So here, guys, we got the x equals 38. We're halfway there. X equals 38. Guess what, folks? We're halfway there. And some of you guys might be wondering, oh, man, Mr. Starkey, but wait a minute. Mr. Starkey, this one here, this angle says y. How in the world are we supposed to do something with the y if what we got is x? You know what, y'all, that's a good question. How are you supposed to do something with the y if what we just found was the x? If what we just found was the x. All right, guys, what you need to do, since we just found the value of x, what you need to do is take one of those expressions for x, like that 3x minus 33. You need to substitute in the value of x that we just now found, so that we can go ahead on and figure out what's the actual measurement of this angle. That's going to help us. First off, since there's nothing else that we can do with x right now to get y, let's plug in x where we can to figure out what's the actual measurement of this angle. Hopefully that makes sense to you. That is something that we can do. We can plug in the value of x here. Anyway, all right, so when we do that, let's plug that in. 3 times 38. When we do 3 times 38, we get 114. 114 minus 33 gives us 81. We plug that in. 81. All right, so guys, the measurement of this angle right here, I told y'all not to assume that it was a right angle. Didn't I tell y'all? Y'all better not assume that it's a right angle. Shoot, it ain't right angle. It ain't a right angle, is it? I told y'all. So if this one is 81 degrees, guys, that means that this one here also has to be 81 degrees. So guys, now that we know what these two angles are, what the measurements of those two vertical angles are, guys, what we need to do is let's find another color here, because I'm trying to color code this so y'all ain't confused by what we doing. You can see the first thing that we did was we found x, right? Okay, just to walk y'all through it real quick, we found x. After we found x, the logical thing to do here was to plug in that value of x into one of these expressions, like 3x minus 33. So we plugged in that value of x, and we got 81 as the measure of this angle. All right, and if that one was 81, that other vertical angle was also 81. Excuse me, y'all. That's my smoker's voice, even though I don't smoke. Anyway, because smoking is bad for you. Empty waste mundo, according to health experts. That ain't according to Mr. Starkey. Empty waste. All right. Alrighty, so let's see here. 81. All right. So guys, what we need to do right here is we need to go ahead on and take that measurement. So y'all, what I'm about to do is going to look kind of sloppy at the moment, but it's meant to help you to kind of visualize what we're looking at here. I'm going to take, oops, that ain't exactly that. I'm going to take part of what that diagram there looks like. Just going to take a part of it. All right, part of that diagram right there. All right, and you see the 2x plus 5. All right, well, we know that that is technically 81 degrees. All right, so if this part here is 81 degrees, yeah, that's just as sloppy as it could be, but guess what? It's going to have to be all right for the day, ain't it? Guess what? It's going to have to be all right for the day. Yeah, yeah. All right, all right, so if we know that that part is 81, and guys, again, I'm just trying to show you a certain part of that diagram where you see that straight line, and you see how we've got the 81 degrees there, and that part with the 2x plus 5, and then so if this part is 81 degrees, that means that really, guys, we don't even need that right there no more. Give me a sec. Yeah, we don't really need that right there no more at all. All we need there is just to look at that 81 degrees. All right, so this angle right here is just 81 degrees. Boom, we know that. Guys, what we know is that these two angles that I'm showing you right here in blue, these two angles that I'm showing you in blue, guys, are a linear pair. And they form a straight line, which means that the total measurement for those two should be 180 degrees. So guys, if the total measurement for these two angles is 180 degrees, let me try to put that in a slightly different color. If the total measurement there has to be 180 degrees, and we know a part of that is 81 degrees, then all we got to do is figure out what else, okay, what plus 81 is going to give us 180 degrees. Now, for some of us, that might be a little difficult. So you can use your angle addition postulate to do that. Now, guys, what we do know is that since we are trying to find what y is, guys, the measurement for this angle was given to us as 4y minus 1 degrees. So we've got 81 degrees and 4y minus 1 degrees. So let's use our angle addition postulate, since we know that these two angles that we're looking at right here that I got in blue, you see it, I'm trying to color code it so you follow where I'm at right now. And in blue, these two angles right here in blue, okay, they add to 180. So let's write out the angle addition postulate for those two. Okay, so if we write that out, I'm trying not to make that look too sloppy, guys. That's 81 plus 4y minus 1 equals 180. And then if we combine our like terms there, we get 80. Okay, so the two constant terms on the left side of the equation are 81 and negative 1. If we combine those, that gives us 80. All right, so that's 80, and we still got the plus 4y, and this is still equal to 180 right now. Let's subtract 80 from both sides. You guys excuse me, because this is about to, okay, well, let's just move it up for a sec here, and that way I won't have to jumble it up so much, or we can make it a little bit smaller. There we go. Hopefully y'all can still see that, even though it's a little bit smaller. That's fine, hopefully that's fine. All right, if we subtract 80 on both sides, that's going to be 4y equals 100. All right, and then, of course, if we divide by 4 on both sides, we can finish solving for y, and we can get that y equals 25. I apologize if this looks a little sloppy, but guess what? Those are our two answers right there. Right there, those are our two answers. All right, so for this one here, this one right here, our two solutions. What color can we use now? Let's try gold. No, I don't like that. Yeah, I do. Let's try gold. We'll do something else. It's okay. Alright, so just so it sort of kind of stands out a little bit amongst all the other colors. Our two solutions here were the fact that x was equal to 38 and y was equal to 25. Okay, now let's see if it's gonna actually do that. I doubt it now. I done made that look so slow. Oh, it did it! It did it! Hey, all right now. Hey, all right now. It did it. It did. Okay. All right, so guys, that's example 5. All right, so folks, here we go. Example 6. If you're looking at this diagram here, guys, when you have a set of angles that appear to go around in a circle with a common vertex, and you see all of these angles here have a common vertex, and again, guys, remember when you have a set of angles that appear to go around in a circle with a common vertex, and again, guys, I tried to sort of kind of remind you a little bit earlier that, again, if you've got all these angles with the same vertex and it sort of kind of appears like they're all, it appears like they all kind of go around in this circle. Guys, you should know and remember that the total amount of degrees in a circle is 360 degrees, right? Think about it. You turn around all the way around, you know, so that you're still facing the same way that you were originally, then you've rotated 360 degrees, right? If all of these angles are going all the way around like in a circle like that, then folks, again, the total amount of degrees there should be 360 degrees. That's all we're saying, okay? All right, I'm going to erase all of that, okay? Because we don't need all that written there for us. All right, but again, that's what we're saying, all right? All right, yeah, we can get rid of all of that. All right, hold on real quick. That thing right there need to go somewhere. All right, so guys, sometimes you'll be able to use that fact that all of the angles there add up to 360, and sometimes you will be able to use that fact to actually help you solve some things. But in this case, guys, in this particular case, that fact is not really as helpful to us as what we might want that to be. All right, so guys, in this particular case, let's start off looking at these two angles that both have x written there, the variable x. Okay, yeah, I thought that was going to be a lot smaller than that. Yeah, there we go. And so, guys, if we look at those two variables, or those two angles that have that variable x in it, those two angles are forming a straight line. Those two angles are a linear pair, guys. And so those two angles that I'm talking about right now, with the give me a sec here, with the x in the variable, they're a linear pair, they're supplementary, and they add to 180 degrees. All right, so again, these two angles right here, okay, that's like half of a circle, right, a semicircle. Again, these two angles add to 180 degrees. They're supplementary, right? So let's go ahead on and set that up and find out what is x. Let's go ahead on and find what's x, and then I'll see if we can erase all of that stuff, that highlighting there. All right, so let's find out what's x. Let's set up what we got here. All right, so if we use our angle addition postulate to write that out, those two angles should add together, and when you add them together, they should be equal to 180 degrees. So that's 2x plus 13 plus 8x minus 43. Let's see here, and those two angles add to give us 180 degrees because they're a linear pair they're supplementary. They add to 180 degrees. All right, we got to hurry up here. 2x plus 8x, combining our like terms on the left side, putting those x's together, that's 10x. All right, if we put the two numbers, the two constant terms together on the left side, 13 and negative 43, when we add those two together, we get negative 30. All right, so that's 10x minus 30 equals 180. All right, let's go ahead on and let's get our constant terms together on one side of the equation. Let's add 30 to both sides. When we do that, we're left with 10x on the left side of the equation. On the right side of the equation, we've got 210 left. All right, so the last step that we need to do is divide by 10 on both sides. Yeah, okay, I thought that was going to look a little bit, yeah, all right. Yeah, it's not going to look any neater. That's okay. For right now, it's going to have to be. All right, so when we divide by 10, we get that x equals 21. Cool beans. All right, so that's one of the things that we needed to find. X equals 21. Great. We know that. Lovely. Awesome. Brilliant. All right, I'm going to erase this stuff that we had here on the diagram because we're going to need to use some other stuff now. All right, bye-bye. So long. Farewell. All right, so we just used those two angles to find out what x is. So guys, let's take what we just found with the x. Let's plug that in, and maybe after we plug in that value of x, maybe we can use those angle measurements for something after we figure out what the value of x actually is. Okay, yeah, that's just sloppy. I'm trying to do this so it actually looked like something when we're looking at this. All right, so again, guys, let's take this, that value of x, let's plug it in there. Give me a sec. Let me separate what we got here. I don't want this to look too sloppy. Let me separate this here thing here. Let me separate that. Give me the big pen. All right. Okay. All right, so if we were to plug in that value of x that we just found, let's see, using this thing here, 8x minus 43. Let's see. All right, so let's do that right there. Let's do that right there now. All right, so let's see, 8x minus 43, plug in our value of x that we just found, which is 21. Okay, 8 times 21 gives us 168, folks. Don't have a calculator on me, but I'm sure that that's 168. Okay. Wait, and that's minus 43. Okay, good. All right, so that's 168 minus 43. When you subtract 43 there, that gives you 125. All right, so the measurement of this angle right here is 125 degrees. Cool. We know that. That can actually help us out, folks. All right, so now that we know that the measurement of this angle is 125, guys, really, we can use that. We can use that. All right, so if we look at this line right here, and if we look at this part right here, at these two angles right here, these two angles, so hold on. For those who don't know which two angles I'm talking about, let me show you which two angles I'm talking about right now. Right now I'm talking about these two angles. Let me get a big pen here. I'm talking about these two angles. This one, yeah, and this one, yeah. All right. Talking about those two angles. So if we look at these two angles that I got the little red dots by, those two angles there are linear pairs, right? And so they're supposed to add to give us 180 degrees, right? I'm going to put a little thingamajiggy here, right? That's like half a circle. Yeah, that doesn't really look like half a circle, does it? Yeah. Still doesn't look much better, but again, it's like half a circle, which is 180 degrees. Again, it's a straight line that's formed there. I'm going to erase that. Those two angles, they form a straight line, and so they add to 180 degrees. So, guys, if we know that if we know that part of that is 125 degrees already, then all we got to do right now is figure out what's the other part of this, so that both of them will add to give us 180 degrees. So if we take these two angle measurements, and I apologize if this looks sloppy, guys, but I'm talking about these two angle measurements right here. Okay. So if we take those two and we add them so that they equal 180. All right. So let's do that, because we know that they're supposed to be equal to 180. Let's take these two angles, and I'm sorry about the sloppiness. I apologize in advance, guys. I really do. Trying to color coordinate this for you, so you got something to look at here that you could tell what I'm sort of kind of trying to get at. All right, so again, these two angles here, that one and this one, they add to 180 degrees, both of those two angles. So one of them is Z, right? And the other one we just found was 125. Those two angles are supposed to add to 180 degrees. All right, so those two angles add to 180 degrees, and so if we do that, subtract 125 from both sides of the equation, minus 125, we get that Z has to be 55. All right, so that's two of our things now found. X equals 21, Z equals 55. Yeah, I was going to show y'all another example like this, but with the amount of time we got left, I'm going to have to just leave it with this example. Yeah, we're going to finish solving this example, and then I got one or two more things to show you, and then we're going to call it quits. Yeah, I was going to show you another example similar to this one, where all of the angles kind of come around, and all together all the angles add to 360. But yeah, we running a little short on time there. All right, what color we gonna use for that? Yeah, okay. Let's go with black. Nah, I don't want to use black. Let's go with. We already did that one. That'll work right there. That's different enough from red and green. Okay. All right, so guys, the next thing that we need to sort of kind of look at is really now that we know what Z is, right? If Z is 55 degrees, folks, and I'm gonna go ahead on and write that in. I'm gonna go ahead on and write that right now. Oops, give me a sec. All right, so if we know that Z is 55 degrees, I'm gonna go ahead on and write that in real quick. All right, this one here is 55 degrees, all right, because we already figured out that Z was at. I don't know if you guys can tell based on looking at that thing. I'm gonna erase what I'm putting right now. But you see that line right there that has the D in there, that has a point D in it, and then you see this line right here that has that point E in it. Those two lines, they form two vertical angles. One of those vertical angles is the 55 degrees right here. And the other vertical angle right here, that one that you see right there, that says 2x plus 13, that one has to be the exact same thing. So if this one is 55 degrees right there for the part that you see as Z, that means that the other one right here has to be 55 degrees. Guys, again, I apologize if it looks sloppy to you, but I'm just trying to explain this one step at a time for you, okay? All right, and again, I'm about to erase what you see right here, where I drew out these two vertical lines for you to see. So so that it doesn't look too jumbled up over here. All right, bye-bye. There we go. We got to hurry this up here. All right, so again, guys, if that one was 55, this one here had to be 55 because they are vertical angles there. Okay? All right, so that one is 55 degrees. Now, guys, if we go back to using to using this color that we said that we were going to try to use there. All right. Guys, if this angle right here, if you see that 90 degrees, that right angle right there, if this angle is 90 degrees right there, then folks, what that means, what's the closest thing we got to that color? Maybe this one here, possibly. What that means is that this one, that means that this angle right here has to be 90 degrees as well, right? Because again, guys, if both of these angles here form a straight line, and I hate to do it like that, but if both of them form a straight line, okay, that means that the total between them is 180 degrees. And again, if one of them is 90, yeah, okay, that's just as sloppy as it can be. And again, guys, if one of them is 90, wow, I thought it was going to do my little thingy where it does. Okay, yeah. If one of them is 90, that means that the other one's going to have to be 90 as well. Now, guys, if this whole thing here is 90 degrees, Lordy, this is so sloppy. I apologize in advance, guys, about this being sloppy. But if this whole thing here has to be 90 degrees, and we already have a part of it, and we know that a part of it is 55 degrees, right? So this whole thing here is 90 degrees on the right side where you see this purple, and a part of it is 55 degrees, then guys, we need to go ahead on and we need to figure out what exactly is this angle right here. We need to figure out what's y using that fact, okay? So these two angles that you see right here with the y and the 55, the y and the 55, they are complementary angles. Okay, I thought it was going to do my little thingy with that. Okay, close enough. They are complementary angles. Yeah, I thought it was close enough. It really ain't. It's okay. All right, that's better. A little bit. Okay. Okay. I apologize, guys, about how sloppy that might look. I'm trying to coordinate this for you, a little bit of color coordination, so you see what we doing and what we dealing with here. All right. So again, these two angles that I have circled with the purple, those two angles are again adding to give you where am I at? Are adding to give you 90 degrees. They're complementary angles. All right, again, guys, they're complementary angles. So let's go ahead on and let's set up that equation. Sorry about that, folks. I had to make sure that we were recording just for a second. Hold on. Yep, okay, we're recording. My bad. Just had to make sure that I'm not talking without actually recording this here. All righty. All right, so let's set up that equation there. And so between those two angles. All right, so again, we said those two angles are complementary angles. Y, the part that says Y, and the 55 degrees that we just found. All right, so those two are complementary angles. They have to add to give us 90 degrees. And so we find out what y is by solving that equation. All right, so if we subtract 55 there, that means that y has to be 35. All All right, so guys, that's all three of those solutions there. And so our solutions are the fact that x equals, what was x? 21. Y equals, what was y? 35. And z was 55. All right, so those were our solutions there. Okay, that ain't what I meant to do. You know what? That's just gonna have to be all right. Okay, I lied. That looks a lot better right there. All right, so guys, next up we're going to just briefly discuss what an angle bisector is, because again, you may see some angle bisectors depending on where you're looking at, either in your next math class or in our final exam. Even if the problems that I'm having you do for this particular lesson don't include angle bisectors, I need you to know what they are and how it looks and when we determine that we have an angle bisector. Okay, guys, we gotta really hurry up here. I said we would talk about angle bisectors, and that's exactly what we're gonna do, guys. Angle bisector. An angle bisector, folks, is a line or part of a line. And guys, and if you remember certain parts of lines, y'all excuse me just for a second. I don't know if you remember, so when we say part of a line, we could be talking about a ray, or we could be talking about a line segment. So, but anyway, an angle bisector is a line or part of a line. And again, when we say part of a line, we could be talking about a ray or a line segment. But it's a line or part of a line that bisects an angle. Remember, guys, that the word bisect means to split into two congruent parts. And remember, guys, that congruent parts have equal measurements. Now, guys, here's an FYI for you. Please do not assume that two angles are, or do not assume that you have an angle bisector just because it might look like, just because the diagram might look like an angle has been split into two congruent parts. Guys, you will only know for sure that an angle has been bisected only if you are given that information. So in other words, if you're literally told, if you're told that like something like, if you're told that ray KM bisects angle LKJ, like if they actually tell you, like what I've got written right here and underlined in red, ray KM bisects angle LKJ, according to this diagram over here. All right, so again, guys, you'll only know for sure that an angle has been bisected if they tell you that information, if that information is given to you, or if you see definitive proof in the diagram. And guys, that definitive proof in the diagram could be things such as congruency marks or equal angle measurements actually written there. So guys, for angles, the congruency marks don't exactly look the same way as the congruency marks look when you have two side lengths. The congruency marks for angles sort of look more like matching parentheses. And again, guys, you might have just like one little thing in an angle like that. Okay, that tells you that two angles are congruent. You could have two things like this right here. I'm going to erase this. You could have three matching things that let you know that these two angles are congruent. But again, guys, as long as you got those matching symbols that sort of look like parentheses, those are congruency marks for angles. All right, we got to hurry this up, folks. So again, you're going to either need to be told that the two angles, or you're going to need to be told that you've got an angle bisector, or you're going to need to see definitive proof, which might be congruency marks, or it might be that the actual angle measurement is written there in the diagram. All right, guys, that's everything for angle bisector. I got one more thing for you. The way that your problems are going to look for this lesson on Delta Math, I'm talking to my students enrolled in my classes at our school. The way that your problems are going to look on Delta Math for this lesson, I got one more thing to show you, and that's how your problems are going to look when you do your practice problems for this lesson. Okay, so guys, this right here is how your practice problems may look when you do your Delta Math. I'm talking to my students enrolled in my classes at our school. You know who you are. Okay, we got to hurry this up here. All right, so they may look like this. Angle C and angle D are supplementary. If the measure of angle C equals 2x plus 4 and the measure of angle D equals 4x minus 6, then find the measure of angle C, find the measure of angle D. All right, so if they look something like this, guys, you may have like one of three options. They may say, let me find the color here. They may say supplementary, like what this one does. If they say supplementary, then guess what, guys? You're gonna have to take those angle measurements and add them to 180, right? Then literally take what you've got. Take the angle measurements that you've been given, the 2x plus 4. You get what I'm saying? You dig? Take those things, add them together. If it says supplementary, I'm trying to show you real quick, so you ain't confused about what you need to do. This is going to be the first thing you do. If it says supplementary, this is what you're going to do. 2x plus 4 plus 4x plus 16 equals 180. That's if it says supplementary. Or, guys, if it says complementary. All right, so that's what you'll do if it says supplementary. If it says complementary, try not to make this look too sloppy, guys. And I apologize if it does. All right, we're a little short on time, so if my writing looks a little sloppy here, I do apologize. Trying to make it look as neat as possible, but we'll have to see. If it says complementary instead of supplementary there, then of course you'll take what you're given and you'll add those two angles, and they'll be equal to 90 degrees. Okay, so this is kind of putting it together. Now, guys, if it says vertical in the problem instead of supplementary or complementary, if it says vertical, if it says that those two angles are vertical angles, oh snap! Hold on. We got to hurry this up. Really, seriously, I don't even care how that looks. If it says vertical, then remember, guys, the vertical angles are always equal to each other. So you take the two measurements and you set them equal to each other. If it says that they're vertical angles, you'll take the two measurements and you'll set them equal to each other. Equals 4x plus 16. And guys, so you'll solve those equations. So that'll be the first thing you'll do. You'll set up an equation based on whether it says supplementary, complementary, or vertical. You will solve those equations. Second step, you will solve for your variable. You're going to have to solve for the variable. Now, guys, some of the problems are literally going to say find x or find whatever the variable is. If that's all it says, then once you solve for the variable, you're done. But guys, if it says something like what it says here, find the measure of angle such and such, then guess what? Once you find your variable, you're not done. If it tells you to find the measure of an angle, okay, I thought it was going to do a little circle thing. I'm a bit of a, I don't know, I'm not OCD, and yet I can be sort of kind of OCD about that. All right, we got to hurry up here. All right, if it says find the measure of angle such and such, then guys, you're going to need to substitute that value of your variable. You're going to need to plug it in. And guys, we did this in several of our examples in the video today, in this lesson today. So you shouldn't have any troubles with knowing what I'm talking about. All right, so you're going to substitute the value of the variable to find the measure of the angle if they ask you for it. Substitute the value of the variable, okay, of the variable. All right, we got to hurry up. I don't even care how this even looks because we out of time. Substitute the value of the variable to find the measure of the angle. To find the angle measurement, we'll put it that way. How about that? Wonderful, lovely, great, awesome. All right, guys, that's it. That's really it. I hope that this has been helpful for you. I gotta go. I really gotta go. Seriously. Bye-bye. Adios. Au revoir.